Ever wonder what really happens in that tiny split second after you type something into an AI and hit enter? It feels like magic, but it's not. Today, we're going to pull back the curtain and decode the AI's central nervous system, the hidden brain that's making all the calls, the LLM router. I mean, seriously, just think about it for a second. 1 minute you're asking it to write a poem, the next you're asking for a complex math problem, and then maybe you want it to search the web. How on earth does it know which hat to wear for each request? Answering that one question, well, that unlocks the entire logic of how these incredible systems actually work. The secret is something called the LLM router. The best way to think about it is like an AI's brain switchboard, or, a super fast digital traffic controller. Its one and only job is to instantly grab your query and route it to the absolute perfect destination, whether that's another AI model, a calculator, or a giant database.
Now, on the surface, this seems pretty simple, right? A question goes in, a route comes out. Easy. But the reality is so much cooler. It's not just a simple A to B mapping. It's actually a high-stakes optimization problem. The router is constantly weighing its options to find the single best path forward.
So, what's all that crazy-looking math really about? Well, it all boils down to this constant three-way tug-of-war. The router is desperately trying to pick the path that is the most accurate, the cheapest to run, and, so important, the safest. It's a nonstop balancing act to give you the smartest, most efficient, and most responsible answer possible. So how does it make that choice? Well, a router isn't just one single thing. It's actually a pretty sophisticated pipeline with a bunch of different stages. So let's follow your query on its little journey through this system, step by step. Your request basically goes on this 5-stop tour. First, it gets cleaned up by the input processor. Then it's turned into numbers at the embedding layer. From there, the intent classifier figures out what you want, the rule engine double-checks everything, and finally, the safety layer gives it the all clear. Okay, first things first. Before anything else can happen, the router has to understand what you're even asking. This whole first phase is about one thing: translating our human language into something a machine can actually understand. And the very first stop for your raw query is the input processor. You can pretty much think of this as the system's official cleanup crew. Its job is super simple. It cleans and standardizes your text. It takes a messy human query like "what's weather?" with weird punctuation and capitalization, and it tidies it up into a perfect "what is weather?" And this is so crucial because, let's be honest, we humans are messy. We use slang, we make typos. This first step makes sure the AI has a perfectly clean slate to work with. Okay, so the text is squeaky clean, but machines run on math, not words. So the very next step is to turn that text into a language the AI can actually compute with, numbers. And that all happens in the embedding layer. This part transforms your query into what's called a numerical vector, which is just a fancy way of saying a long list of numbers. But here's the magic. These numbers don't just represent the words, they capture the semantic meaning. This is how an AI knows that weather today and what's the climate like are basically the same question, even though the words are totally different. All right, so now the router understands what you've asked. Now it's time for the decision-making parts to kick in. This is where the system really starts to think and, to act. So the router has this meaningful vector of numbers. Its next job is to figure out your goal. What are you actually trying to do here? That's the job of the intent classifier. It analyzes that vector and sorts your query into a predefined bucket, like chat or search, or in this case, calculation. It sees what is 25 times 4, and it immediately knows, aha, that's a math problem, let's send it down the path with the calculator. This is the first really crucial decision that points your request down the right road. But, machine learning isn't perfect. Sometimes it can get a little uncertain. And that's why any real-world system has a super powerful backup, the rule engine. Think of the rule engine as the bouncer. It's a non-negotiable, common-sense override. It's got these hard-coded instructions. So even if the fancy machine learning part gets confused, the rule engine steps in and says, nope, the user wrote current time, so we are calling the time API. End of story. It's a critical fail-safe to stop the AI from making simple, obvious mistakes. We are almost there. The system has a plan, but before a single action is taken, the query has to pass one final critical checkpoint. And this is the safety layer. Its job is completely non-negotiable. Block anything that's harmful, dangerous, or inappropriate. It is the final gatekeeper, and it's there to protect both the system and you, the user, and to make sure the AI is behaving responsibly. You simply cannot build a modern AI system without this. It's fundamental. So we've seen the whole pipeline. We know all the parts. But this is where we need to zoom out. Because the real game here isn't just about sorting requests into different buckets. The philosophy behind router design is so much bigger than that. And it's what really defines the intelligence of the entire system. And this right here is the key takeaway. Building an LLM router is not just a simple classification problem. It's a deep, fascinating problem of decision theory and optimization. You aren't just putting labels on things. You're architecting the entire nervous system for an artificial intelligence. You're deciding how it thinks, how it prioritizes, and how it acts. And this quote just says it all, doesn't it? Router design determines how intelligence flows through a system. Every single decision it makes, every path it chooses, that's what shapes the very nature of the AI's response. It's what turns a big collection of different tools into a single, coherent intelligence. Which leaves us with a really fascinating final thought. We are at the very, very beginning of this field. As these AI systems get more skills, more tools, more models to choose from, these brain switchboards are going to need to become exponentially more intelligent themselves. So the big question is, what will that next generation of routers look like? The answer to that, well, it's probably going to define the entire future of AI.